guys, Dr. Burns here. We are ready to start Chapter 5, which is the second chapter in our second unit, and we're looking at probability. In Chapter 4, we focused on scatter plots and regression lines, and that gave us information about the correlation between two numerical variables. In this chapter, we're going to look a little bit more at correlations and relationships between two categorical variables. So we're going to start off by looking at some concepts related to probability and calculating probabilities in general. Make sure your cell phone is put away so you're not distracted by any notifications and you have the sound turned up and you're ready to take notes. I want to start off in this section talking about the idea of randomness. That's a tough thing to achieve in the real world just by hand. Usually when we want to randomly select items from something, we use technology to help us do that. And so we're going to use StatCrunch from time to time to help us generate random simulations, for example. And what does that mean? Well, randomness means that there's just no pattern to it. It's just all over the place and there's no identifying pattern. So random means having, we can just say no pattern here. It's like it sounds, completely random. And like I said, people generally aren't good at doing that on their own. We usually use technology to help us. So probability is what we use to measure the likelihood of a random event occurring. So we can say probability is used to measure the likelihood of a given event occurring. And there's two main types of probability that we're going to discuss. The first is theoretical probability. And the second is empirical probability. Let's start with theoretical probability. This is the one, if you did any probability in high school, this is probably the one you talked most about. And when we think of what is the chance of something happening, the chance of flipping a coin and it landing on heads is 50%, for example. That's the theoretical probability. In theory, what should happen? Sometimes we think about this as the relative frequency or how often a given event will occur after, let's say, an infinite number of simulations. So in other words, if we were to repeat this an infinite number of times in the long run behavior, what is the chance of something happening? So we could think of it as the long run likelihood of an event. Okay, so don't overthink this, but what we're just saying is, in theory, what should happen? 50% of the time when I flip a coin, it should land on heads. When I roll a die, every 1 out of 6 times I roll a die, it should land on a 2, for example. Now, does that always happen when I actually roll a die or when I flip a coin a certain number of times? No, and that is called the empirical probability. So the empirical probability are relative frequencies based on let's say on an experiment or a simulation of a real life process. So in other words, if I actually roll that die 10 times, how many times does it land on a 2, for example? What happens in my experiment? That's called an empirical probability. Sometimes that will match the theoretical probability, but oftentimes it will not. It just depends, and it depends on how many times you're conducting that experiment. Let's look at a couple quick examples here to kind of drive home what we mean by the difference in these two probabilities. The first one says, your friend claims that the probability of getting a 6 when rolling a 6-sided die is 1 out of 6, because the die is equally likely to land on any of the 6 sides. So this is what should happen in theory. In theory, if I roll a 6-sided die, a fair 6-sided die, and it's equally likely to land on any of the sides, 1 out of 6 chance of me landing on a 6. So that would be the theoretical probability. In theory, 1 out of 6 times I should end up on a 6. Now the next example says, a classmate is trying to figure out the probability of getting 3 heads when flipping 3 coins. So in order to do this, he flips 3 coins 10 times, and in one of those 10 times, all 3 coins landed on heads up. So on the basis of this outcome, he claims the probability of 3 heads on one flip is 1 out of 10 or 10%. So he simulated this 10 times, or he actually did it 10 times, and only one of those flips did it land on 3 heads. So since it's based on what's happening right in front of him on the experiment that he's conducting, that means this is the empirical probability. You might have heard in science class, your teacher mentioned empirical evidence. That's what you do when you conduct an experiment, right? That what do you see in that experiment? That's called empirical evidence. Sometimes when we talk about in the court, we'll have empirical evidence of a crime or something like that. That's what we mean. It's based on observation and what we actually see occurring. Couple of other little remarks about this. Theoretical probabilities, so theoretical probabilities are exactly, I think I was looking for consistent maybe is a word here, or equal. In other words, what I mean by that is the probability of landing on a 6 when I roll a die is 1 out of 6 every time in theory. The theoretical probability is always 1 out of 6. That never changes. However, empirical probabilities, because they are based on the experiment that occurs at a given time, they change with every experiment. They're not consistent. So empirical probabilities are going to be inconsistent. And you'll get the hang of this. This isn't too bad. We'll look at some examples in class so you can see what the difference is a little bit more in detail. Why do we have 2 probability models? Well, theoretical probabilities are sometimes hard to compute. Let's write that. So theoretical probabilities in the real world, what is the probability that a given person will get a certain type of cancer, for example? We can't know that with absolute certainty. So instead we have to conduct experiments and look at the numbers that way and look at the data that way. So theoretical probabilities are often difficult to compute. However, empirical probabilities can help us to estimate those theoretical probabilities. So I may not know without a doubt what is the theoretical probability that a person over the age of 50 will get, I don't know, colon cancer. So what researchers would do is they would collect data and they would look at lots and lots of data on people with colon cancer, and based on that they would say the chance or the percentage or the likelihood of somebody over that age of 50, for example, getting colon cancer is 5% or whatever that ends up being. And so that's the empirical probability, but they would use it to estimate the theoretical probability. Additionally, we cannot always trust the theoretical probability model. Sometimes it's based on faulty assumptions, and so the empirical model can help us to verify or refute a theoretical value. Finally, simulations. Simulations are experiments, and they may be on a computer, literally simulated, used to predict empirical probabilities. So we'll see a few simulations in class where we'll use StatCrunch and a few other websites to actually run some simulations, drawing random numbers, for example, and looking at different empirical probabilities.